Greetings to all. I am Dr. G. Saktivel, Assistant Professor, Department of Electrical and Electronics Engineering, Kamraj College of Engineering and Technology. In this video lecture, I am going to discuss about inverters and what is an inverter and the applications of inverters, classification of inverters and the major types, single phase half bridge inverter and full bridge inverters. So, first important thing is what is an inverter? So, inverter is a static device that converts DC power into an AC power at desired output voltage and output frequency, that is said to be an inverter. So, we can get variable output voltage at variable frequency, that is the purpose why we are using an inverter. And next one is applications of inverters. In industries we are using variable speed drives. For that purpose, in order to achieve variable speed, we are using inverters. So, to get variable speed drives, we are in need to vary the speed of the machine by varying either by varying the voltage or by varying the frequency. Either by changing the voltage or by varying the frequency, we can get variable speed. So, that can be achieved by using with the help of an inverter. Next one application of an inverter is induction heating, and in aircraft power supplies we are using inverters, and in UPS we are using inverters. Application of inverters. So, according to the method of commutation, the inverters are classified as either it is line commutated inverter or it forced commutator inverter. What is meant by commutation? Commutation is nothing but the process of turning off thyristors used in the circuit, that is said to be commutation. In line commutation, with the help of supply itself, the current that is flowing through the thyristor is made to be 0. So, the switch is turned off by natural process. So, that is called line commutation. And in forced commutation technique, we are using elements like inductor or capacitor in order to make the current that is flowing through the switches to become 0, and that type of circuit is said to be forced commutation. And in our circuit, if you are employing line commutation, means due to the presence of supply voltage itself, the switches are made to be turned off, and that type of inverters are said to be line commutated inverter. Whereas, if you are employing another device, another components like L and C and make the switching device to turn off state, then that type of inverters are said to be forced commutated inverters. And the important thing is, line commutators are generally commonly used in HVDC system, that is high voltage DC systems, where power is transmitted from DC to AC grid, that is here DC to AC conversion process is involved. And next case is a forced commutated inverter. These are also similar to DC to AC inverters, and here we are employing this forced commutation technique. Wherever the line commutation technique is not possible, here we are employing this type of forced commutation technique, and that type of inverters are generally used in variable frequency drives. Variable frequency drives are represented as VFD, and either it may be used in standalone inverters or it may be used in power electronic converters which are used for our renewable energy systems. Next one is, the inverters are further classified into the method of connections. They are classified as series inverter, parallel inverter and bridge type inverters. In the case of series inverter, the load is connected in series with the commutating components, that is we are using L and C, inductor and capacitor as the commutating components, and in this series inverter the output is sinusoidal waveform and which may have some oscillations, and these type of series inverters are used for low frequency, and it can be only used for low power applications, it cannot be used for high power applications due to certain limitations. And the second type is parallel inverter, and in parallel inverter the load is connected in parallel with the commutating components, that is L and C, and this parallel inverter can be used for high frequency applications, and when compared to series inverter, this parallel inverter is less efficient, and the external and the main drawback in parallel inverter is the requirement of external commutation circuits. And the last type is bridge type inverter, and this bridge type inverters are mainly used for variety of industrial applications, and in this bridge type inverters we are using MOSFET or IGBT as a switching device, or we can go with SCRs, that is thyristor. The main application of bridge type inverters are either they are used in motor drives and in various renewable energy systems. Next classification of inverter is depending on the nature of DC source that is given as input to the inverter, they are classified as either voltage source inverter or it may be classified as current source inverter. So, what is a voltage source inverter? So, voltage source inverter which has a constant DC voltage source at the input, and the source has low internal impedance, and in the case of voltage source inverter, the output voltage waveform which is controlled, whereas output current that is dependent on load. And the main key features of voltage source inverter is this voltage source inverter require large capacitor at the input side in order to provide the constant voltage, and the most commonly used in industrial applications are voltage source inverter, and the main applications are AC motor drives and they are used in UPS etc. And next second category is current source inverter. A current source inverter which has a constant current source at the input and the source has high internal impedance, and the output current is dependent and it can be controlled, whereas the voltage is dependent only on the load. And the key features of the current source inverter are the output current is regulated, not the voltage, and the main drawback of current source inverter is the requirement of large inductor at the input side, and this current source inverters are less commonly used but important in specific industrial applications wherever the current control is required. At that case we can go with current source inverters. Next one is we are going to discuss about single phase inverter, and in that single phase inverter we are going to discuss about half bridge inverter and full bridge inverter. So, this is the circuit diagram for single phase half bridge inverter, and the single phase half bridge inverter consists of a voltage source Vs, and here we are using two switches S1 and S2, and here we are using diodes D1 and D2, and in general we are considering the load as a resistive and there is no need to use the diodes. And if you are using resistive RL load type, at that case the diode D1 and D2 will come into play. So, this is the in general, this is the circuit diagram, and here we are having the waveform, load voltage, current through the switch 1, current through the switch 2 and the load current. So, during the time period 0 to t by 2, this is the time period 0 to t by 2, during this instant the switch S1 is turned on whereas the S2 is turned off. So, the current flow will be like this from positive terminal of the battery and then to the switch and then to the load and then to the negative terminal of the battery. So, the output voltage waveform will be like this. So, this is what we are getting the voltage during the time period 0 to t by 2, and during this time period the current will flow through the switch 1. At that particular case the current flow through the switch will be equal to 0 and the load current will be like this during the time period 0 to t by 2. And next time period is, first time period is 0 to t by 2, second time period is t by 2 to t. This is the total time period, and in this time period second instant the switch S1 is turned off and the switch S2 is turned on. So, the current flow will be like this from positive terminal of the battery and then to the load and then to the switch and the current flow will be like this, and during this period the voltage we will get will be negative. So, this is the time period T by 2 to T by 2, and this duration the switch S2 will conduct, and the load current will be negative. So, the above cycle is continuously repeating for single phase half bridge inverter. Full bridge inverter, this is the circuit diagram for single phase full bridge inverter, and Vs is the supply voltage, and here we are having 4 switches, they are numbered as S1, S2, S3 and S4, and in this circuit also we are using diodes, and the diodes will come into play whenever we are using the load as RL load, and the working will be like this. So, this is the first time period 0 to T by 2. During this time period the switch 1 S1 is turned on and S2 is turned on, S3 and S4 is turned off. So, the current flow will be like this from positive terminal of the battery, then to the switch 1 and then to the load and then to the switch 2 and then to the negative terminal of the battery. So, the output voltage we will get will be like this, that will be equal to Vs, and the current flow will be flowing through the switch 1 during this time period. And next time period is T by 2 to T. During this time period the switch S3 and S4 is turned on, whereas S1 and S2 is in off state. So, during this time period the flow will be like this, that is from the negative terminal of the battery and then to the load and then to the switch 3 and then to the supply voltage. So, here also at the same instant 2 switches are connected. So, the current flow will be flowing through the switch and we will get the output voltage during this time period T by 2 to T, that is also the. So, this is the working of single phase full bridge inverter. So, in this video lecture what we have discussed is what is an inverter and the applications of inverter, and then the classifications of inverter and the working of single phase half bridge inverter and single phase full bridge inverter. Thank you.